MathWorks academic webinar series. This series is a sequence of technical online seminars that we designed specifically for you, for academics in research and in teaching. So starting today, we will do 2 webinars per week. On Wednesdays, we will have a technical topic, and then on the following Tuesday, we have a webinar that talks about how to teach this particular topic with our tools and workflows. All the webinars start at 1500 Central European Time. Now, before we dive into today's topic, let me briefly run through some logistics. Do not be alarmed if you do not find your mute button. So if you've muted yourself and your lines to keep the noise level under control. And number 2, I encourage you to ask questions during this webinar. If you do have a question, please use the chat box. And if possible at all, please make sure to pick the option to all participants. We have engineers on this call today, and we will try to answer your questions as quickly as possible and in real time. Now, right after the presentation, we will do a live Q&A. And during this live Q&A, our presenters will answer some of your most popular questions. All right, it's time to get started, and it's time to welcome our presenters for today. And it's my great pleasure to introduce to you Sheila Shelanga from the Cambridge office. Hi, Sheila.
Hi, Misha. Hello, everyone.
And Carlos Sanchez from the Madrid office in Spain. Buenos días, Carlos.
Buenos días, Misha. Hi, everyone.
All right, good to see you guys. Sheila, I'll turn over to you. The floor is yours.
Thank you, Misha. So, hello, everyone, and welcome to this webinar. Can you see my screen? Can you type mouse in the chat if you can see my screen? Just double check. Yes, yes. Okay, great. Okay, let's start. So today we will share with you some good practices and examples for virtual student engagement that professors around the world have developed with our collaboration. My name is Sheila Shalanga, and I'm here co-hosting this event with my colleague Carlos Sanchez. We are part of the academia team at MathWorks, and we are scientists and engineers and health faculty members all around EMEA with MATLAB and Simulink in the teaching and research. I like to do this session interactively, so feel free to ask questions along the way. I will ask you a few as well. For asking questions, please use the chat and address all the questions to all the participants. So what we will do today is that we will walk through some of the most common steps a professor encounters when planning a course. So Carlos and I will put ourselves in the shoes of professors that are teaching system dynamic course. So firstly, we want to present clearly to students the objectives of the course and how these fit into their career path. So give them the guidance to review the content that will be necessary during the course and make them familiar with the tool that they will be using, since this will place a common baseline for our course. Then it's time to build the content of the lectures and provide them support with both course notes and additional self-paced material. We will also like to include some projects or labs to test their learning and apply what they've been learning during the lectures. Lastly, during our course, we would like to have a frequent update on the learning progress of the students. So we included these 5 points in our agenda today. And for each of them, you will see how we included MATLAB-based tools. So let's start with discussing the objective and establish a common baseline for our course. So if you are not familiar with MathWorks, I guess that you're familiar with MATLAB and Simulink. MATLAB is a programming environment that allows you to perform numerical analysis, data visualization, algorithm development, or anything involving numerical computation. So it's a high-level language which is designed to be intuitive and easy to learn. It includes around 100 toolboxes, which are essentially packages of algorithms, functions, and applications that have been designed for use in a specific area of science and engineering. In addition, Simulink is built on top of MATLAB and is a graphical environment for designing, simulating, and testing systems. is also a natural tool for model-based design, where you can design and simulate your system before moving to hardware. Both MATLAB and Simulink have a very broad range of applications, from aerospace and automotive industries, communication, but also medical devices. We are very proud of our customers, and we love to share their success. So on our website, we have plenty of user stories that you can use, for example, in your course to motivate and inspire your students. So let me ask you something. So if you have already used MATLAB and Simulink for teaching or research, for example, can you type MATLAB in the chat? Many MATLAB. That's great. Okay. So nowadays, most of the universities offer a campus-wide access to MATLAB, and everyone from faculty to students and staff can download MATLAB into their university or personal computer and work offline, or work from the browser with MATLAB online. So to find out if your school is covered under the campus-wide access, you can go to mathworks.com/academia and check the eligibility. Your school might already have a dedicated portal page where you can find all the resources for learning and teaching. So to start my course, as the first step, I will ask my students to download MATLAB on their machines before the start. Then, whether my course is an introduction to system dynamics or a master course where the students might have different background, this is a very common framework for what happens during a master course. I want to give my students the tools to learn the programming basics at their own pace. So on mathworks.com, students can access free online trainings directly from the browser to get an introduction to MATLAB and Simulink. So let me show you how this looks like. So I'm now jumping to the browser, and these on-ramp courses take around 2-3 hours to complete and will set a common baseline for the class, allowing more productive use during your labs. So they guide usually students through the learning with videos, examples, and exercises to test their knowledge. So concepts that you teach in your courses may already be developed as part of our self-paced courses. Some instructors assign this on-ramp as a first homework or lab, so you don't have to spend valuable class time teaching MATLAB and can focus on the course content. So let me show you how one of these sections look like. I will just log in the section 2 about commands. You will see here next each section the time that the student should spend to complete. So each of these sections is divided, the screen will be divided in two parts. On the left, there will be some description of the exercise that the students will have to solve, and then the specific task that they are required to solve. So I'm going to go to these building functions, where there is an introduction on the variables and how to define a variable, where my task is to define a variable x equal to pi half. So I'm doing that, and then I click enter, and I will get a feedback that says that my solution is correct. Then click in space. I will go to the second task, where I have an introduction on the absolute value, on the eigenvalues, and then the description of the task asks to define a variable y with the sign function with the variable x. So let's say that I'm not sure how this function should be. Instead of typing sign, instead of typing sin, I type sign. So I will do an error just to show you how this looks like, and I will click enter. So now what I get here is a feedback. So that tells me how I could fix my solution, so I can see that my answer is wrong, but I get how I can fix it. So if I click ask and I type it again, modifying and doing this correctly, I will get my positive feedback. So to summarize, in this session, we saw how to help students to get started with programming, giving them the tools for a self-paced learning that include real-world examples and feedbacks. So now Carlos will show us how we can make our lectures more interactive, helping students to get a deeper understanding on the topic.
Thank you, Sheila. So, as many of you know, I'm sure many of you moved to online teaching. And as you probably have experienced, students have many things competing for their attention. So when lecturing, especially when lecturing online, how can we make the lectures as graphical and as interactive as possible? My first proposal is going to be, let me switch to MATLAB, that before we even start writing any math or any programming, we're going to motivate our course on dynamic systems with the example that you see on my screen right now. We could discuss with the students how could we model the suspension of a vehicle. And as you probably, this is a classical example, and as you know, it can be modeled as a mass spring damper system. And before we even dive into the math, I've provided my students with the app that you are seeing on the left. This is a MATLAB app. It was built with MATLAB, but I don't need to type any code to actually run it. I only need to interact with it graphically. So for instance, in this way, we could start having a discussion about how would you, my students, expect the system to behave, that is to move over the x-axis over time, when I change the mass? Or what would you expect if we have a much stronger spring or a much stronger damper? Or what happens when I change the initial conditions, like the position or the velocity? And that way they can start building intuitions that will help us later on when we dive into the math. So the app that you're seeing right here, let's see how I opened it up. I'm going to close it, and in my MATLAB, I'm going to go to the Apps tab. In the upper part of MATLAB, there is a tool strip with different options, and one of them is Apps. In the Apps tab, there's an Apps dropdown in which you can select from a different set of, from a number of icons, and each of them opens different tools. Like for instance, curve fitting tool allows you to do regression without even have to write any code. These are all apps that come with the toolboxes that I have installed. But the one I showed you, that I did custom for my class, and I can find it over here under my apps. Let's very briefly take a look at how I designed that. I'm going to open up this folder that we'll share with you afterwards with all the code and all the examples. And I'm going to open this file over here that has an interesting extension. Instead of the familiar .m, this is a .ml app. So it's a MATLAB app. When I double click on it, you're going to see a tool called App Designer. Many of you might be familiar with its predecessor, that is Guide. The aim of App Designer is to make it as graphical as possible to create an app. So I basically have a canvas in the middle, and I can select from a number of different components here on the left. And I can, for instance, select a button, I add it, I position it, I have some guides, and then I modify its aspect. And on the right, I have all the other properties that it has. Now, to program how the user should interact with these, you have to go to callbacks. And in callbacks, you're going to create a function that will handle the event of whatever happened, like pushing a button. In my case, I have already created a function that does all the legwork. And I'm not going to get into the details, but I do want to highlight something. First and foremost, there are gray areas that I cannot edit, and those App Designer creates for me to reflect all the things that I did graphically in the design view. In the highlighted parts is where I write my code, which allows me to focus on the things that are relevant for my course, for the concepts that I'm trying to teach. Another thing I want to highlight is that I'm calling an external function, simsolve, which is the function that I created to actually solve the differential equation. Now, I highlight that because you can edit the app as much as you want. At each point in time, you can run it and see the modifications, like this big button that we added. And once you're ready to share, you have three options. You can either share the app as a standalone app, that is a Windows app, a Linux app, a Mac app. You can share it as a web app, and that way students would access access it through a web browser. But these two options have their limitations. The first one means that the app will be specific to an operating system. And the second one means that I need to set up a web browser. And it's something, you need a software that you can download from our website, which is called MATLAB Web App Server. This one, as a MATLAB app, I will be able to share a single file that anyone can install wherever they can run MATLAB, even on MATLAB Online, as we'll see later. And when I click on that, I get an assistant that is going to do many things for me. Like, for instance, I can input some details like my name, and I can put in my email address, my university. But I also want to highlight how MATLAB was smart enough to identify that I'm relying on this external function, and it's suggesting that I include this in the package. And once I package that, there will be a single file that my students need to install. And lastly, if you choose to distribute that file through our community website, that is File Exchange, students will be able to install it from within MATLAB by just clicking the add-ons button. And there they will get basically a browser for additional things that they can download and install in their MATLAB. And this could be your app. Okay, so let's sum up very briefly what we saw. Basically, you've seen that there are a number of different apps available with the toolboxes that you already have installed and which are part of your licenses, and those you can find in the Apps tab. We've also seen that you can get many more apps from our community sites, from File Exchange, and we've seen how you can edit custom apps that will help students develop intuitions, and you do that with App Designer. Now, so we've basically given students a turnkey solution to experiment with a simple system. And now it's time to actually get to understand the math and be able to solve it in MATLAB. To do that a little bit more simple, we're going to use an interactive notebook interface, which is called Live Editor. Live Editor will basically allow us to, let me switch to MATLAB again. Live Editor allows us to do a lot more than you can do with a simple script. Let's open up an example. And again, it's a not so familiar extension. It's a .mlx. That is a live script. So in a live script, you basically see a document in which I'm explaining. I'm going to double click here so it occupies all the real estate available. So I'm introducing the example that we saw in class to my students. I'm documenting it with images and links. And I'm also introducing equations. I can do that in two ways. I can either insert LaTeX, and you'll get a pre-visualization as you insert it, or if you're more comfortable with a graphical tool, you can insert an equation with this editor that you see over here, where you get basically a set of options like Greek symbols and mathematical operators, and then a number of different symbols like integral, a sum, and all of that. So going back to my example for dynamic systems, we basically laid out the equation for the spring, for the damper, and now we do a balance where mass times acceleration is equal to the forces that are applied, and we arrive at a second order differential equations, which we're going to solve. Now, to solve an equation computationally often involves a numerical process and sometimes an approximate process. But students might not be familiar, especially in the first courses, with a process like that, whereas they are familiar with how they work in a notebook or how they work in the Blackboard. So to make it a little bit closer to that experience, we're going to use symbolic math. The idea with symbolic math is that whereas you normally type MATLAB commands and MATLAB gives you numerical approximations of the result, with symbolic math, you basically are telling MATLAB to operate with the variables that I'm giving you as if they were just symbols that you don't have to substitute for numerical approximations. And with those symbolic variables that you define with the sims command, you can define functions based on them. You can operate with those functions. You can differentiate, you can integrate, and you can plot, as you'll see in a minute. So up until here, we've basically done laid out the foundations, and now let's go to solving the equation. As you can see with symbolic math, writing an equation like this is pretty straightforward. This is pretty much the same notation that I'm using above, with just a double equal sign to differentiate between a sign in a variable and an inequality relationship. You can also see that once I input this, MATLAB recognizes this as an algebraic expression, and that's why it's correctly formatted. And now I'm going to define, I'm going to substitute the numerical values, define the initial conditions, and finally solve with the dsolve command. And again, the solution is not a number, it's not an array, it's an expression, and I can plot it over time, and I get that familiar result. So we see professors use LiveScript in two different ways. One is as a way to enhance the lectures. So instead of using slides, I could use this, and it's interactive. But I could also use this as a handout for my students, where instead of having the code in these gray boxes, I would have empty boxes that they need to fill in. And as they fill them in, they will get to results that are in here telling the full story of the computations that they did, and they can compare with the app that we saw at the beginning. And wrapping up, Live Editor has allowed us to basically go from just writing code to actually telling a story with not just how I'm doing it, which is the code, but also what I'm getting, which is the results. And I'm also documenting that, augmenting it with text, images, equations, etc. And so we've gone from just discussing concepts and experimenting with a turnkey solution that was our app to actually writing the code in a less intimidating way through Live Editor and Symbolic Math Toolbox. And now it's time for the students to actually get to dive deep into this and learn themselves. And Sheila is going to tell us how you can help your students with their self-paced study.
Thank you, Carlos. So give me 2 seconds while I share my screen again. Okay, here we are. So I previously showed you some on-ramp courses to introduce MATLAB and Simulink to students, but additional courses are available online that can be integrated in lectures to give an introduction or refresh of mathematical topics as nonlinear equations, ODEs, linear algebra, but also statistics. So lecturers usually use these courses to supplement and replace lectures, so they can use the class time to dive deeper into domain-specific examples. Additionally, more advanced courses drive the learning beyond the basics on popular topics like deep learning, machine learning, but also data processing and financial applications. So if your course of the course that you are teaching include one of these topics or the previous mathematical topics that I show you, can you type yes in the chat? Wow, okay. That's great, because in the next weeks, we will have dedicated webinars for teaching these topics, but also how to use these tools for research. So check the calendar and register. In addition, each course provides a certificate that you can include the course plan, and you can verify which sections were completed by the students. And finally, MATLAB Fundamentals provides a comprehensive introduction to common features and workflow in MATLAB. The lessons range from 30 minutes to 2 hours, and furthermore, this training can help your students to get ready for the MATLAB professional certification. So to summarize again, in this session, we saw the online courses available on our website that we can assign to our students to encourage individual self-paced study. Additionally, through the course, I would like to assign some homework to verify the learning status of my class. Traditional assignment asks students to submit a homework that you will grade and provide feedback in 1 or 2 weeks. But we would like to have an environment when I can write the exercise and students can solve the problem while getting an instant grade at a personalized feedback. With MATLAB Grader, you can create interactive course assignments with automatic grading. So you can use the same environment to share the assignment, data files, and example codes. Plus, students will submit their code and get an immediate feedback. So they can revisit the problem and use your feedback to better their solution. let's see how I can use Grader in my course, where I'm introducing my students to MATLAB and to solve the exercise that Carol showed you about the mass spring and damper. So I'm now in the browser, and MATLAB Grader can be accessed through the browser at grader.mathworks.com. I'm already in my course of System Dynamics, where I'm at week 1, and I want to test the MATLAB skills of my students. I already assigned them the MATLAB on-ramp, and I want to verify their learning. So I'm going to jump to my first exercise. And what I'm going to ask them is to use some trigonometric function and plot the results. So let me show you what the students will see. I'm going to the learner preview here. And on the top, there will be a problem description where I can include figures, text, code, LaTeX. And then on the bottom, there is a window where the student can write their own solution. And at the end, there are the assessment that will run to grade the exercise. So let me solve this for you. So what I have to do here is to create a vector y with a sine function x with amplitude 2. And then in the second part, I have to plot these same variables that will be the x variable for the x-axis and the y variable in the y-axis. And then this exercise asks me to plot this line with a red dashed dot. So I know that red is R, but let's say that I misread, or maybe I just don't know how to do this, how to do the dashed dot line. So I will submit my solution in this way. So what students will see here is that they may pass the first 5 tests while failing the last one. So also they will see a feedback here that in this case, there is a link to documentation and they can check how they can improve the solution. But you can also include link to your course or to videos if you prefer. So checking this feedback, I can go back to my solution, improve it, and then submit it again. Now, let me jump back to my role of professor. And what I want to do is to write a new assignment for the student. So how do I start? So let's say now I'm in week 2, so to the assignment 2, and I click to the add problem here. So there are many options here. So I can start from a blank problem, so starting from scratch, or I can look for one of the problem in the problem bank that is offered by MathWorks. So depending on what you're teaching, there may be some assignment that will be very useful for your course. So what I'm going to do is to go to this Getting Started with MATLAB Grader, and scrolling down, I will see there is an example on mass spring and damper system that fits my course. So I will copy this in my homework. So then scrolling to the bottom right, I will set it as a draft. So this will allow me to modify the title, modify the description in case I want to add more details for my student or put in links to my course. And then there will be this reference solution that is the one provided that will match the one from the student. And the other one, the learner template, will be what the student will see. So in this case, there is this blocker that means that the student cannot modify this line. So if I have some other parameters, like in this example, that I don't want the students to modify, I will put the locker and they will see this line as freeze, so they cannot modify. And then in the second part, there are the assessment. So you can tailor any feedback, adding a link to the documentation page, course note, so you can provide the student a better feedback than your answer is wrong. So next Tuesday, we are hosting a MATLAB Grader webinar that will focus on building a course from scratch. So if you're interested in using this tool in your course or have specific questions, it's a good opportunity to learn more. So as student complete assignment, the grades go right to your gradebook. But you not only get grades, you also get performance analytics that help you to keep control of the class learning. So you can see the solution map based on the time of arrival and distance from the reference solution. Plus, you have access to the complete history of the student attempt to find the correct solution. So what we just saw is how we can have interactive auto-graded assessment with MATLAB Grader and include it to test the entry level of the students and track their learning. So the instant feedback, it's very strong because it motivates students to continue and to improve their solution. And also this provides a way to gamify your assignment and keep the students more engaged and motivated. Additionally, MATLAB Grader can be integrated in your learning management system like Moodle, Blackboard, or Canvas. And this allows the learning and homework content to be available in one single environment. So MATLAB Grader in your LMS will be available to the campus-wide licensed universities in time for next academic year. But if you're interested in getting access now, please get in touch with us and we can arrange that. Also, you can find more information on the website, mathworks.com. So to summarize, we saw how to introduce students to programming and test their knowledge. But what if I want my student to work on some individual or group project? Carlos, can you show us something?
Thank you, Sheila. So let me, so that the aim here is, without physical facilities, without access to a lab or a computer room, how can we do the sort of work that we used to do in person, to put the concepts into practice with projects and more complex assignments? So we're going to see different options that are going to be right for different types of courses. First and foremost, students can install their own copy of MATLAB with the campus-wide license on any computer. But it could happen that they don't have access to a powerful enough computer, or they don't have enough space on it. And an option in those cases can be MATLAB Online, which, as we'll see, is a version of MATLAB that you access on a browser. Another option could be MATLAB Mobile, which is essentially the same, specifically tailored for tablet devices and smartphones, with some additional benefits that we'll see in a minute. So how do you move to MATLAB Online or to MATLAB Mobile? Well, you can put your files on a folder in MATLAB Drive, and that will allow you to synchronize it and access it anywhere you are. Let's take a look at that. So I'm going to open up the files that you've been seeing on my MATLAB session. You have the URL over here. I know it's a little bit long. Just in case, I'm going to paste the address on the chat window, or if my colleagues can do that. There you go. And once you click on that, you will have to log in and accept the invitation to the folder. I'm going to open up my MATLAB online session where I have already accepted the invitation to the folder, and I'm already in that folder. So as you can see, I'm in MATLAB. I'm in a special MATLAB environment. What I did was I opened up a browser and I typed matlab.mathworks.com. I had to log in, and then I'm presented with an interface that is pretty much the same MATLAB you're used to, but within a browser. So as you can see, I have the folder on the left, and I have the command window on the right, and you can pretty much do anything you can do on MATLAB, save for the moment opening up Simulink. Simulink is not yet available online, but save for that, most things work, even apps. So on the left, you have the same files that you saw before, and this time around, we're going to open up a different live script in which we're going to look at the same familiar mass spring damper example, but this time around, we're going to look at how to solve it numerically with ODE for 5. As I did before, I'm going to double click over here so the script occupies as much real estate as possible, and I'm going to hide the tool strip by double clicking on it. So this script is thought as an example of how you could use a live script as a handout. And we're going to go through different exercises for our students. First, I introduce the theory, which is no more than ODE for 5 expects a specific variable change that you implement with a function like this, displacement.m. And that could be the first exercise for the students, to just write the code for that variable change They have an array with the position and its derivative. Then we're going to set initial conditions. First, there's a time span of 0 to 10 seconds, and the initial conditions are position 0 and velocity 1 meter per second. And then the final exercise is they have to fill in this box, which would be empty, to solve the problem numerically. Maybe we would give them these 2 lines, and then they have to type the one with ODE for 5, and they solve this. And I'm using something that I didn't show before, which is interactive controls. Maybe once we've solved the exercise, we want our students to play around with the constants and see how they affect the result. And inserting these controls with insert control makes for a more interactive experience. They don't need to modify the code, they just play around with this. So wrapping up, MATLAB Online gives you access with no installation, no download, anywhere you are, just with a good internet connection. It allows you to collaborate with colleagues or with your students by sharing a folder. And by the way, let me go back, I didn't show that. So the way you share a folder is, what I did before this session is you click on the folder, either on MATLAB Online or on regular MATLAB, you click share, and you have 2 options. You can either invite colleagues via their email so they can edit, or you can create a link, and that's the link that I pasted on the chat window, so you have read-only access to these files. So again, we've accessed MATLAB with no installation. We've been able to collaborate and send the link to our students so they can access the exercises, and it synchronizes so I can keep working with my files anywhere. And you access MATLAB Online with matlab.mathworks.com. All right, so before we move on to that, so that means that everyone can experience MATLAB anywhere, but you probably want to experience, you probably want to work with physical signals of different sorts. What if your students had a lab, a pocket-sized lab with them all the time? Well, it so happens that they do have smartphones, and smartphones have a variety of sensors, including a camera. What you're seeing on the left is MATLAB Mobile, and I'm taking a picture of a cup on my desktop, and I'm going to do a quick example of image processing. I'm going to take the picture, then I will make it grayscale, and I will extract the edges with the edge command. So we've also seen people do interesting things like studying a parabolic throw by just using the sensors in a smartphone and throwing it, and then you look at the accelerometer, all sorts of things like that. So that can make for an interesting practice, but you probably have courses with more complex lab assignments. And that the solution to that might be a virtual lab. So wrapping up MATLAB Mobile, we've connected to the cloud to compute, we've used sensor data, we've captured images. But let's go on to a virtual lab, a more complex environment where I can model any type of system. Well, that is pretty much what we aim to do with Simulink. Simulink is a graphical environment with which you can model all sorts of systems, like, for instance, control systems. That's a very classical application, or signal processing, communication systems, and systems of many different sorts. Let me switch back to MATLAB and back to my course, where we're going to look again at the same mass spring damper example, but what you're seeing here is a more complex system. The mass spring damper served to motivate the course, but we probably want to build more complex systems than this. And to come up with a simple enough, but also complex enough system, how about we connect a mass spring damper system to another mass spring damper system? In that case, even if that is still simple conceptually, to write the equations for the movement of the second mass explicitly is not evident. So we've done that through simulation here in Simulink. And basically what you're having here is we have position. Through an integrator, we get velocity. Through another integrator, we get acceleration. And then we've connected the same on top of that. So we can simulate this and look at the result. and here's the evolution of the position of mass 2, and here's the evolution of the position of mass 1. And the advantage of doing it in Simulink is that it's a graphical environment and it's a systems level environment where I can, for instance, take this and say, this is going to be a subsystem now. I don't care about the details. That allows you to work at different levels. But still, what I'm doing is translating an equation to a graphical form. It's a flow of data, and that is the arrows, and transformations over those data, that is the boxes. How about I could model, what if I could model a system just the way I would draw it on a board, on a blackboard? That is what you have on the right. Instead of classical Simulink, I'm using a set of toolboxes called Simscape. So you have the ground over here, and I have damper, a spring, the mass. So I have the elements that are part of my system and the physical connections between them. And in the simulation that you saw before, we are comparing the results of classical Simulink with Simscape, in which case Simscape is inferring the equations for us. So, wrapping up, with physical modeling, you can model all sorts of systems, be it electrical, hydraulic, mechanical, fluids, just the way you would draw them conceptually, just physical components and physical connections. But it's not just that you can do mechanical systems or electrical systems or hydraulic systems. You can combine it with classical Simulink models, and you can even combine different types of systems, like maybe mechanical and electrical and controls. So you get mechatronic systems like the one you're seeing on the screen right now. And then anything you do in Simulink doesn't have to just live in Simulink and be simulation. You can convert that to something that you are going to see move. So your students might have around them low-cost hardware like Raspberry Pis, Arduinos, maybe Legos. What you have on the left right here is a Lego Mindstorm. It's a configurable robot that I can give, to which I can give any shape. There's a programmable part to it. And what we've done is we've converted the thing that is on the left, which is the model for a Rubik's Cube solver, and we've flashed that into the programmable part. What is happening behind the scenes is a code generation process. Basically, we're converting your Simulink model, but it could also be your MATLAB code, into equivalent C code or HDL code, etc. And you don't just have to do this with low-cost hardware, educational hardware. You can also do this with all sorts of equipment like high-speed cameras, FPGAs, ASICs, etc. You will find all of the supported devices in mathworks.com/hardware support. And there you will find instructions to go about that. So, in a nutshell, we've gone from giving access to students anywhere they are through MATLAB Online and collaborating in the cloud, to experimenting with physical signals that you have available just with a smartphone, to simulating more complex environments, optionally with Simscape, if the complexity of the system merits that. And then you can take your model and convert it into the actual system, the actual programmable device. And with that, these are the tools that we've discussed. And before we move on to Q&A and to the pending questions that we didn't have time to answer in the chat window, let me just recap very quickly. First and foremost, you can give your students access today before even they come to the first class through the MATLAB portal. And if you don't happen to have one, you can talk to our sales representatives, and they can come up with a solution for your university. Then there's an online course that dives deeper into all the tools that we saw today interactively. So you would get to experience Live Editor and MATLAB Grader in more detail, and you can access that through the same training platform that you saw earlier. That's mathworks.com/academic training. And finally, we, on a day-to-day basis, we collaborate with academics all around the world on all sorts of subjects Sometimes it's building curriculum materials. Sometimes it's other kinds of collaboration. So we'd like to be in touch with you. And we're a largish team of engineers. And if you want to get in touch with us, please write to us to this email address. And there will likely be an academic engineer in an office close to your location.
Fantastic. Thank you very much, Carlos. Thank you very much, Sheila. We're now moving to the live Q&A session. And while we were presenting and you were listening and paying attention and asking questions, we did collect some questions. And one of the first ones, the ones that has been asked several times, will there be a recording and an access link for this webinar? So this question I can answer. We have not recorded this webinar, but we will share the presentation materials and examples with you after this presentation. All right. Another question that I saw come up a couple of times: can MATLAB Grader also assess Simulink models?
So I can.
Please go ahead.
Okay, yeah. What I was going to say is officially Simulink is not supported, but I don't know if Carlos can add more details. For what I know is you can run Simulink models, but it will not be in the same environment as you see in Simulink.
Yeah, well, as you probably know, you can run Simulink models programmatically with the same command, and that would work in MATLAB Grader. So if your assignment doesn't involve modifying a model, but just playing around with parameters, that could be a solution.
Exactly, yeah.
All right, the next question that came up at least twice or three times: how do I find out if my university has a campus license? I know you showed this quickly, Carlos, I believe. Can you just show this again?
Of course. So the quickest thing, so URLs are hard to remember. So I would say, if you go to mathworks.com, there's an academia section that is specifically aimed at students, professors. So one of the first things that you will find here is, does your school have access to a campus-wide license? If you click here and you give us an email address, we will reply with whether you have access already. And if you have, it would look something like this. This is a MATLAB portal. These are specific to universities with a campus-wide license. And in here, you have all you need to access the software, technical support, and training.
Fantastic. Can MATLAB Grader be integrated with a LMS? LMS are learning management systems.
Yeah, that's a big yes. So that's possible. So we have in our websites some instructions on how this can be done on Blackboard, Canva, the Moodle, but yeah, this can be definitely done. The only thing is will be necessary to get in touch with your LMS manager in the university, but yeah, this can be done for sure. So if you can join us next Tuesday, we will have another webinar about MATLAB Grader, and we will show how the integration is possible and how it looks like in these systems.
Exactly, yes. So tune in next week, Tuesday, same time, same place, and we will talk a lot more about MATLAB Grader and integration with learning management systems.
Yeah.
Then there was a question about apps. Actually, two questions, two short questions. Can apps be compiled? Was number one. And number two, can apps be created from all toolboxes?
Maybe I'll take that one. So first, can they be compiled? Yes. You do that through MATLAB compiler, and that will create an executable, either an exe for Windows, a DMG for Mac, an EL for Linux. So the quickest way to do that is in App Designer itself. You go to Share, and you click Standalone Desktop App. If you're on Windows, it would be creating a Windows app. If you're on Linux, it would be creating a Linux app, etc. It will present you with an assistant that guides you through the steps, and the end result is an executable, but the user needs to also install a runtime. It's something that they install once and works for any other compiled MATLAB app. You can download that from our website, or you can include it in the package, although then it will be heavier. And the second question was, can you do it out of any toolbox?
Yes. Is it just limited to one particular or two toolboxes, or is it really something that you can do for pretty much all toolboxes? Right.
So to clarify, I guess what that means is, can I use code from any toolbox within my code? And the answer is the answer is yes. Compiling MATLAB code is generic and is not specific to MATLAB apps. And you could use any code. MATLAB will know to include the dependencies. It doesn't even have to. If the user has the runtime, it will work.
Fantastic. All right. Since we're now in a GUI in the app tool, there was a related question. How can you access the code of a GUI, for example, to edit an existing app and to adjust it to what I needed to do?
Maybe we touched on it briefly in the chat window, but let me elaborate. So most our apps have the option to generate equivalent MATLAB code. So this, for instance, is curve fitting tool. And I'm going to load just some sample data. It's population data, and I want to adjust it, and maybe I choose power for there too, whatever. So once I'm done with whatever work I'm doing in the app, I can go to File, Generate Code. And that is going to give me equivalent MATLAB code to what I did graphically. And I can examine this code and then dive deeper. And for instance, I would learn that fit is the command that is actually doing the work. And I can go to help, learn much more, and modify my code.
Great. Is there something like Simulink Online, the equivalent to MATLAB Online, or is it the same?
I would say not yet, but soon.
Okay. I'm looking at the time. Maybe two more questions. The one is about hardware and controlling or accessing hardware through the browser. And I would probably assume that the question is, can you control hardware, program and control hardware through MATLAB Online, for example?
You can for some devices. For instance, you can work with a Raspberry Pi. I'm not sure if I'll be able to locate the example, but I know it's published on our website somewhere. Let me, MATLAB Online, I'm going to search. I think it's in our documentation. There you go. So connect to Raspberry Pi hardware board in MATLAB Online. And I believe there are plans to expand this to some devices. I would say if you're working with more advanced hardware for the moment, the easiest would be to do it offline, because it's probably not going to be supported. But for some devices like Raspberry Pi, it is.
Great. Okay, then maybe one final question. Is there a catalog that shows which lab course hardware integrates well with MATLAB? So I guess the question is, if I'm looking for hardware for my lab course, how do I find out if this hardware is supported by MathWorks tools?
Well, the easiest would be to go to mathworks.com/hardware support. And in there, you can filter, like, for instance, if you're searching for something, you might say, I want something related to FPGAs. And in here, you would select the device that works best. or if you already have something, you might search for the specific device. And I'm typing something very generic, but it could be, sorry, I'm going to remove this filter. But you could input the specific name of the device. This typically goes by families. So for instance, Texas Instrument support from Embedded Coder, it will list the number of devices that are supported.
Great. Thank you very much, both you, Sheila and Carlos, and all our colleagues who were very quick to respond to questions today. This brings us to the end of our webinar. I have a couple of quick announcements before we say goodbye to you guys. Let me see if I can quickly share my screen.